Hello students, and welcome to the continuing lesson on parametric equations. And in this video we are going to look at some examples of writing parametrizations or parametric equations using 2 points and writing equations for a line. So we'll start out with the most basic example and work with lines only. Okay? And it says here, write a parametrization for a line through 3, 4, and 6, -3. So what we're going to start out with here is a graph of the points. So if I just needed to graph these points, it shouldn't be too difficult to do. I'm going to have 1, 2, 3. Let me label my scale here. 4, 5, 6. So 1, 2, 3. So a point that goes from 3, 4 to 6, -3. 6, -3. Okay, and I need somehow to get a parametrization of this, and a parametrization is just really two equations. One equation for the horizontal movement, okay, and then one equation for the vertical movement. So let's just look at the horizontal movement. Well, it starts out at 3 and it goes over to 6. Okay? And again, one of the nice things about parametric equations is that it allows us to ignore one of the directions and just create a graph in terms of the other one. So I'm going to ignore what this line here does. And in fact, let me draw the line in here. Okay? So the line starts from 3, 4 and it goes through 6, 3. So we just ignore the horizontal for a minute here. So for the horizontal, we know that it, ignore the vertical. So for the horizontal, we know that it starts at 3. And then it's going to move 3 to the right. And so we can graph that, and with our equation being x is equal to 3, that's the starting point, plus 3t. And similarly, for the vertical, we are starting at 4 and we're going down 7. So that equation is going to be y equals 4 minus 7t. Now, if you're thinking, why do we have to start at this point? Why can't we start at this point? It doesn't specify here, so you could start at either point and go towards the other. And these are the two equations that we have to work with at our disposal. And so, just to get some practice into graphing this, let's try this on our TI-83, TI-84 graphing calculator. And the first thing that you want to do here is hit the mode button, and then go down to where it says function parametric. If you have the TI-83, it might say func par pol seek instead of writing out the word, so you just want it to be in parametric mode. Hit the y equals button, and you can see now it's a little bit different. It allows you, every time you graph, you have to graph two equations, one for x and one for y. So for the x, I'm going to type 3 plus 3t. For y, I'm going to type 4 minus 7t. And these are the equations we had earlier. If you hit the window button, you see things are a little bit different here. You have some max and min values for t as well. So I'm going to go t from -10 to +10, and I'll explain what this means and the significance of it in the latter examples. T steps is the increments of t. Now, if you make this really big, it's going to draw the graph very fast and very sloppily. If you make this very small, it's going to draw this graph very slowly but very accurately. And so for an example like this, I like to go somewhere in between small and big, and I'm going to make it about 0.2. So this is between -10 and 10. So this is going to make about 20, 40, no, it's going to make about 40 different steps for t, okay? And that'll give me a good balance between accuracy and speed. X min, we'll just use as a standard window for now. Okay. Same with the Y values. And then hit graph. And you can see there it is, a nice looking graph of the equation. And just to prove my point a little bit, I can make t-step very, very small. So if I go 0.001 and I hit graph, whoops, what did I do here? Let's see here, window. Oh, maybe I made my t-steps too small. So we'll go 0.01 instead. And let's try to graph this. And it should be drawing this picture here, but it might take a very, very long time to draw this picture. Okay, so there you go. You can see it moves through there very, very slowly. Okay, but it's going to give you a nice and accurate graph. Now if I go back here and go back to my window, if I go back into my window, and this time I make this t-step a little bit, or much bigger. Let's say I made this 5, okay, I hit in there. Now for lines, it's not going to make a big difference, but when we get to curves, the t-steps will be very significant. Okay, but that's it. We're done for the first part. Now let's go on to the second part of the problem. And I'm going to erase some of the work that I had before, and let's continue. This time, actually I don't need to erase too much. I want to modify answer to graph a line segment. Okay. A line segment between 3, 4, and 6, -3. So instead of a full-blown line this time, all I want is a line segment. And to get a line segment, what we really need to do here, nothing very special, is we just need to restrict the values of t. So we just need to figure out what's the smallest value of t that we can use here, and what's the biggest value of t that we can use here. Well, we know that x at its smallest is at 3, and at its biggest is at 6. So we can try this. If I put in 3 for x, and I solve for t, I'm going to get 0 is equal to 3t, so 0 equals t. And then for 6, well, I'm going to get 3 plus 3t, 3 equals 3t, so 1 equals t. So I'm going to have the exact same answer as before, but for a line segment, all I need to do is restrict t. So t can only be between 1 and 0 in this case. And I found these numbers by looking at the smallest x value and the biggest x value. Now you might be thinking, well, why don't I use y values? Why did I pick 3 and 6? Why didn't I choose 4 and -3? You can definitely do that. You can use 4 and -3 and use it for the equation for y, and you should get the exact same answer. That's the beauty of a parametric equation. You could solve, if you have both x and y, you can use either of these equations to solve for t, and if you do this correctly, you should get the same answer. So, so this is my answer. It's the same thing as before, but for a line segment, you just need to, these equations don't change, you just need to restrict the values of t. So let's go back into our graph here, and remember, t should be 0 at its smallest, and 1 at its biggest. And I'm going to have to make the t-step a little bit smaller here. If I hit graph, and there you have it. Okay, so this is a little bit new to if you haven't seen parametric mode before. It allows you to graph something, graph any equation that you had before in function mode, but this time you're able to graph just portions of it by restricting this t value. All right, and let me finish out with the final example here. So what if instead of using parametric mode, I want to convert this back into function mode? Okay? So I have one final example here. This time I want to convert answer to a function of y. Whoops, I'm writing this stuff way off the screen. Convert function to a function of y in terms of x. So I have these two equations. X equals 3 plus 3t, and y equals 4 minus 7t. And I want to convert this to just one equation. And you can see some of the pluses and the minuses of parametric equations versus function. Parametric equations are nice because they allow you to work with 3 variables, but sometimes you may only want to or may only need to work with with 2 of those 3 variables. And this is also called eliminating the parameter. Okay? And the parameter in most cases is going to be t. So basically we're trying to eliminate t, remove t from the picture here. So we can do this by just a couple quick steps. Just solve one equation for t, then substitute into the other equation. So solve one equation for t and then substitute it into the other equation. And in these examples, it doesn't particularly matter much. So I'm just going to solve the first one for t. Okay, so I'm going to solve this one. So I get x minus 3 equals 3t. Divide both sides by 3. I get x minus 3 over 3 is equal to t. And then we are going to take that and substitute. We're going to substitute into the other equation. So now I get y equals 4 minus 7t, but we already know that t is x minus 3 over 3. And now I'm just going to work out the rest of this problem. Y equals 4 minus, distribute this 7x plus 21 over 3. And then we can separate this 4 minus 7x over 3 plus 21 over 3, which is equal to 4 minus 7x over 3 plus 7, because that's 21 over 3. And finally, y equals negative 7/3 x plus 11. And so what this whole problem is saying is that this equation here, which is a line with slope negative 7/3 and y-intercept 11, is the exact same graph that I would get if I graph this set of parametric equations. And there's advantages and disadvantages to both. With this one, if I know x, I can use it to solve for y. I don't need to solve for t and then solve it for y. If I know y, I can solve it for x. However, this one here allows me to work in terms of 3 variables. If t represented time, x and y represented position, I'm able to graph all 3 variables, and I'm able to solve equations. If I'm given 2 of them, I can solve for the other, or if I'm given 1 of them, I can solve for the other 2. Okay, so there you have it. A couple of examples here on how to work with parametric equations. You should continue on and watch the next video where we talk about the Pythagorean identity and how to solve parametric equations when you're working with circular motion. Thank you for watching, and have a wonderful day.